Okay, and today is the third. Okay, and a self-inverse function is a function that equals its inverse, so, i.e. f of x equals its inverse. So for example, if I've got find the inverse for function f of x equals 1 over x, so if I want to find the inverse of this, I start off with y equals 1 over x, then swap our x and y's, then make y the subject, so multiply both sides by y, so yx equals 1, divide both sides by x, and I get y equals 1 over x. So our inverse is also equal to 1 over x, okay? So our function is 1 over x, the inverse is 1 over x, so that is a self-inverse, okay? Easy enough? It works for if it's something over something, depending on the function. So show f of x equals x over x minus 1 is a self-inverse function. So do the same thing here. Oops, and I wasn't recording any of that. So here's the working for showing that this is a self-inverse function. All good? Okay. Have a go at this. Find the value of k such that f of x equals 3x minus 5 over x plus k is a self-inverse function. Okay. All right, so first off, I'm going to let it...
But I got the right answer.
What answer did you get?
The answer. For the inverse.
Let's just see. So, I've got my y equals, I swap my x and y's. X equals 3y minus 5 over y plus k. Right, next step.
You multiply by y plus k.
Multiply by y plus k, so I get x y plus k equals 3y minus 5. Next step.
I did a weird method, okay?
I added 5 first here.
It still worked.
I added 5.
No.
I did add 5.
No.
But, okay, let's not add 5 then.
Like, our aim is to get the y's by itself. It's the same as this previous one. Like, when we did this one, what did I do at this point? Expanded, okay?
Yeah.
So I'm going to expand. So I get xy plus xk equals 3y minus 5. Next step.
No.
No,
No?
I'm not adding 5. I want this -5 to stay on this side. What is my aim? To isolate y, okay? I've got y's here, I've got y's here. What did I do in my previous example? So, no, not yet. I've got y's here, I've got y's here. I've got y's here, I've got y's here. What did we do? We put our x to the other side and we get all of our y's together.
I did x and y. I did x, y, y.
So then you subtract 3y and subtract x.
Right, I'm going to subtract 3y. I'll do that first. So I get xy minus 3y plus xk equals -5. Then I'm going to subtract xk. So I get xy minus 3y equals -5 minus, I'll write it as kx. I've got all my y's on the one side, yes? Everything else on the other. Yes? It's the same as what we did before. What do I do next?
Factor out y.
Factorize out y. Yep, because by doing that, then it isolates the y by itself. So I get x minus 3 is equal to -5 minus kx. Then to finish it off, divide by x minus 3. This, you're pretty much guaranteed to get not necessarily a question like this, but you will have to find the inverse of something like this, okay, where you're going to have to follow these steps. And then to finish it, I write my inverse is equal to -5 minus kx, x minus 3. Yeah, correct, it doesn't look the same. Okay, now, if this is a self-inverse, then this has to be the same as this. Yep, so I'm going to write down, I've got 3x minus 5 over x plus k, that's my original function, yep. Has to be the same as, now I'm going to put it in the same order, so I've got minus kx minus 5 on the top, and then I've got x minus 3. Yep. So what's the value, what is the only value that k can take in order for these two things to be the same? Has to be -3, yes. Because if I put -3 into this, I get -3, which becomes +3, so I get my 3x minus 5. If I put -3 here, in this one, I get x minus 3, which will be the same as on this side.